Guys, I'm going to try this again. This is actually my second attempt. We're looking at 5-7 today. You will be able to see me. I can't see what I'm doing on the screen, guys, so bear with me. And I know I have to point the opposite. So let's talk about the hinge theorem over here. Okay. Hinge theorem is same as side angle side inequality. What it says is if you have two triangles, and each set of two triangles has two congruent sides, then the one with the biggest angle in between them has the biggest opposite side. For example, we're looking over here at ABC and XYZ. AB and AC are congruent to XY and XZ respectively. Angle A is bigger than X, so that tells me BC is bigger than YZ. Just like that door, guys. Small angle, small opposite side. I'm not changing these two side lengths, just a third. It gets bigger as that angle gets bigger. Okay? I'm going to pause this so you guys don't have to look at this mug the whole video. If anyone has too much work, you guys just have to deal with me. Okay. Let's take a look at how this works. One inequality relates Ln to OQ. Okay. Well, this side is congruent to this side. This side is congruent to this side. So we have a side angle side inequality. Measure of angle M is greater than the measure of angle P, right? So Ln is going to be greater than OQ. Because if M is the bigger angle, it's going to have the bigger opposite side. Okay? Let's take a look at 1B. We might have to draw a picture. So we have ABC and PQR. Okay, they tell us AB is 3, BC is 4, and CA is 6. PQ is 3, QR is 5, and RP is 6. Use indirect reasoning to say that P is greater than angle A. Okay. So this side's congruent to this side. This side's congruent to this side. So what can we do? We can say that measure of angle P has to be greater than the measure of angle A by the SAS inequality theorem. Okay. Because BC is less than QR. Okay. Smaller side, smaller angle. Bigger side, bigger angle. Okay. I mean, that's all there is to it. Let's look at another one. How do we know that the one blade is open bigger than the other one? Well, hinge theorem states that if two sides are congruent, then triangle with bigger angle has bigger side. Okay? Sorry, lost video, guys. Computer's going a little bit choppy, so I'm going onward and forward. Okay, theorem 514, converse of the hinge theorem. What this says is the same thing as before, but what it comes down to is bigger side then we'll have the bigger angle. Okay, these two sides have to be congruent, and then the angle in between. Okay, So if this angle is bigger than that angle, then that side is bigger than that side. Okay. Gave you seconds to draw some pictures. Okay. What is the range of possible values for x in the figure at the right? Okay. These two sides are congruent. These two sides are congruent. This is the bigger side, right? So this is going to be the bigger angle. And it's 90 degrees, right? So that means, oops, angle K is going to be less than, the measure of angle K is going to be less than the measure of angle N, right? So that tells me, well, K is 3x plus 18, right? N is 90. So I set 3x plus 18 less than 90. Okay, you don't set them equal to each other now, you find out which one's bigger. You set this one less. Then I do some good old-fashioned algebra. I'll even start green. I subtract my 18, subtract 18. 3x is less than 72. Divide by 3. Divide by 3. And that is what? 24? X is less than 24. And that's our range, guys. X is less than 24. But wait a second, range. We gotta do one other thing too. This has to be greater than 0. Okay? Always, when that's for range, set greater than 0 as well. Okay? So I subtract my 18, subtract my 18, 3x greater than negative 18. X has to be greater than negative 6. Okay, so my final answer is x has to be between negative 6 and 24. You guys want? I'll do another example like this one in class before we get started because I understand this is tricky, guys. This is tricky. So I'll do another example if you guys want in class. That's fine. A proof, if this is A degrees and O is the midpoint, show that LM has to be greater than MN. Okay. Statements, reasons. Box. Okay. I'm going to go like this and say given, right? Cutting corners. We got time. Okay. So here's what we do next. I want to say LO is congruent to no. By O is a midpoint, guys. And I have to use it, so I'm going to use it right away. Okay. Now we need a side, angle, side for this. Not congruent though, we just need to know stuff about side, angle, and side. What do we know about MO? Well, yeah, that's congruent to MO. By good old reflexive. Okay. Now here's my big question for you. I want to skip some steps. Don't tell anybody we're skipping steps. If that's 80 degrees, what do you know about this angle? What do we know about it? We know measure of angle LOM plus 80 equals 180, right? Because they are a linear pair. So then could I say measure of angle LOM equals 100 by our good old subtraction property? Yeah, because we subtracted 80 from both sides. Okay. Now, nice job, Mr. Williger. Those are definitely not parallel lines. Can I say that the measure of angle LOM is greater than the measure of angle MON? Yeah, I can. It's just a fact, right? Oh no, definition of angle measure. We'll skip that one for now because it's not important. So, we have two congruent sides. We have a bigger angle than the other. So how can I say this is bigger? By the hinge theorem. So now I can say that LM is greater than ON by the hinge theorem. And we're done. Guys, again, ask me to do a problem like the one before we go on. Enjoy!